Welcome back, my dear students. So this is today the second lesson of electric fields and charges. In the last lesson, we mainly discussed the properties of electric charges. So I will give a recap. What are the properties of electric charges? Like charges repel, unlike charges attract. Charge is conserved, charge is additive in nature, charge is quantized. And last class, we learned one important formula. Quantization of charge Q is equal to plus or minus Ne. What is N? N is an integer and E is the charge of an electron. Today, we will do some numericals related to quantization of electric charge. Okay, and Coulomb's law. So, quantization of electric charge, what is the basic equation? Q is equal to plus or minus Ne. Using this, I am going to calculate the number of charges in 1 coulomb of charge. So this is the formula. Q is equal to plus or minus Ne. Okay. Question 1. Calculate the number of charges, number of electrons present in 1 coulomb of charge. So here charge is given. What is charge? 1 coulomb. And you know the basic unit of charge. E equals 1.6 into 10 raised to minus 19 coulomb. Okay. And you can use the formula Q is equal to Ne, right? So what is N? Q by E. Q is 1 coulomb. Charge of electron 1.6 into 10 raised to minus 19. When you calculate, you will get it as 6.25 into 10 raised to 18 electrons. So this is the number of electrons in 1 coulomb of charge. So it is a very simple calculation, right? Now, one more question I am giving. It is from the textbook. 1 minute. I will give the question first. The question in the example 1.2. If 10 raised to 9 electrons move out to another body every second, how much time is required to get a total charge of 1 coulomb? Okay. So read the question. It is given 10 raised to 9 electrons move out of a body to another body every second. So you remember how many electrons move out of the body? 10 raised to 9 electrons move out of the body to another body every second. In 1 second, 10 raised to 9 electrons are moving out. So question is here, 10 raised to 9 electrons move out of a body to another body every second. How much time required to get a total charge of 1 coulomb on other body? Here also basic formula you have to use is Q is equal to plus or minus Ne. So 10 raised to 9 electrons move out. So what is N here? 10 raised to 9. It is for every second. Okay. How much time required to get a total charge of 1 coulomb? So what is the charge moved in 1 second? Q is equal to 10 raised to 9 into 1.6 into 10 raised to minus 19 coulomb. This is for every second. So this is the charge moved for every second. What is our question? How much time is required to get a total charge of 1 coulomb? So time. This charge is removed for every second. So what is the time required to get a charge of 1 coulomb? Time is equal to 1 coulomb charge divided by how many charges are removed to the other body in 1 second. 1 second this much charge. So for the other body to get 1 coulomb charge, how much time is required? This divided by 10 raised to 9 into 1.6 into 10 raised to minus 19. You have to calculate it. When you are calculating, what you will get? 6.25 into 10 to the power 11 seconds. If you convert it, it is in seconds. If you convert it into years, you will get time as 200 years nearly. Okay. So you can see that to transfer 1 coulomb charge to another body. So at the rate of 10 raised to 9 electrons per second, how many time is needed? 200 years. So from this, you can understand that Coulomb is a very large quantity, very large unit. That is why when you do numericals, you can see that charge is always given in microcoulomb, picocoulomb, nanocoulomb, etc. Okay. So read the question once again. If 10 raised to 9 electrons move out of a body to another body every second, in 1 second, how many charge electrons are removed? 10 raised to 9. So what is the charge of 10 raised to 9 electrons? Q is equal to Ne. So 10 raised to 9 into 1.6 into 10 raised to minus 19 coulomb. This is removed from one body to another body for every second. Second body is receiving this charge. Second body must contain this 1 coulomb charge. Should receive 1 coulomb charge. How much time is needed? That is a question. So time is 1 coulomb divided by how much charge is transferred in 1 second. 10 raised to 9 into 1.6 into 10 raised to minus 19. So you get 6.25 into 10 raised to 11 seconds. So answer is 200 years. Now we will do one more question from the textbook. I will give the question. This is example 1.3. How much positive and negative charges is there in 1 cup of water? How much positive and negative charge is there in 1 cup of water? So, in 1 cup of water, you may have an idea of how much water is contained in a cup of water. Let us assume that it is 250 grams. Okay. So, mass of 1 cup of water, mass of 1 cup of water, we take it as 250 grams. You need to find out how much positive and negative charges is there in a cup of water. That is a question. So you need to use the formula Q is equal to NE. Then you can find out the charge. Mass of 1 cup of water is 250 grams. And you know the molecular mass of water. Okay. Molecular mass of water. It is 18 grams. 1 mole of water contains 18 grams. Okay. And you know this 18 grams containing how many electrons? 18 gram contains how many molecules? How many molecules? 1 point, you know, Avogadro number 6.022 into 10 raised to 23 molecules. 18 gram contains 6.022 into 10 raised to 23 molecules. So what will be the number of molecules contained in 1 gram? You have to divide by 18. Therefore, 1 gram contains how many molecules? 6.022 into 10 raised to 23 divided by 18. Okay. This is the number of molecules contained in 1 gram of water. Now you can find out the number of molecules in 250 gram of water. Okay. Number of molecules in 250 gram of water. How will you find out? You have to multiply 250 into 1 gram contains 6.023 into 10 raised to 23 by 18. So number of molecules in 250 gram of water is 250 into 6.02 into 10 raised to 23 divided by 18. This will be the number of molecules in 250 gram of water. Now, in one molecule, can you tell how many positive charge and negative charges are there? In H2O, how many electrons are in one molecule of H2O? How many electrons are there? And how many protons are there? You know, in oxygen, 8 protons and 8 electrons. So 8 protons are there. Water molecule contains 2 hydrogen atoms, 2 protons are there. So in one molecule, there are 10 protons. Similarly, there are 10 electrons. Okay. In one molecule of water, number of electrons 10, number of protons also 10. Also equal 10. So in one molecule, how many positive charges are there? 10 electrons are there, 10 into E. How many positive charges there? 10 into E. So what will be the total number of total charge in 250 gram in one molecule? Okay. In one molecule, charge, negative charge. Negative charge equals this 10 into 1.6 into 10 raised to minus 19. Therefore, in 250 gram, total negative charge equals, you know, number of molecules in 250 gram of water, 250 into 6.023 divided by 18 into 10 raised to 23 into 10 into 1.6 into 10 raised to minus 19. So here, which equation we use? Q is equal to Ne only. Formula used is Q equals Ne, right? N is N into, so total number of molecules into charge. When you calculate this, what will be the answer? You have to calculate the answer. You will get answer 1.34 into 10 raised to 7. You calculate yourself. It will be 1.34 into 10 raised to 7 Coulomb. Protons also same, because number of protons and electrons in one molecule is same. This is a number of negative charge. Okay, total positive charge. Same thing. So this is how we use the formula of quantization of electric charge. Now, I'm going to the next topic. It is a very important topic. It is a law called Coulomb's law. And Coulomb's law is an inverse square law. You learned Newton's law of gravitation, force between two masses. That force is inversely proportional to square of the distance between the masses. Here we learned the force between two point charges. It is also inversely proportional to the square of the distance between the charges. That is why it is known as inverse square law. So this law is very important law, Coulomb's law. One important thing you have to remember here is this Coulomb's law is valid only for point charges, point sized charges. Charge size is very small. Okay, negligible dimension we can say, very point sized charges. So Coulomb's law is applicable only for point charges. This you have to keep in your mind. Now you consider 2 point charges. Name it as Q1 and Q2. They are separated by a distance R. F is the force between them. Then this F is proportional to the product of the magnitude of the charges. This force is inversely proportional to the square of the distance between the two charges. So we can combine these two facts. So F proportional to Q1 Q2 by R square. So F equals K Q1 Q2 by R square. This small k is a constant. This constant depends on the medium in which the charges are placed. Okay, so k is a constant. Its value depends on the medium in which the charges are placed. So this is Coulomb's law. So we can state Coulomb's law now. The electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the charges. So what is the statement? The electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the charges. What is the equation in mathematical form? F is equal to F equal to Q1 K Q1 Q2 by R square. What are these Q1 and Q2? Q1 and Q2 are point charges. R is the distance between them. F is the force. So the K is a constant of proportionality. This constant value depends on the medium in which the charges are placed. Suppose the charges are placed in vacuum or air. Then the constant is given by this equation, 1 by 4 pi epsilon 0. 4 pi epsilon 0. This epsilon 0 is known as the permittivity of the air or vacuum. Permittivity. So the word permittivity, permission, right? So what is this permittivity? It is a measure of the ability of the medium to transmit electric force, electrostatic force. That is known as permittivity. It is different for different media. For air, we denote it as epsilon 0, and its value is given by 8.854 into 10 raised to minus 12. Okay. Coulomb square per Newton meter square. This is the value of epsilon 0. And if you find value of K, 1 by 4 pi, if you put the value of epsilon 0, this will be 9 into 10 raised to 9. The value of K will be 9 into 10 raised to 9 Newton meter square per Coulomb square. Okay. If the charges are placed in a different medium, not in air, other than air or vacuum, in any other medium, we write the force as 1 by 4 pi epsilon, not epsilon 0. Epsilon is for any medium other than air or vacuum. Q1, Q2 by R square. Okay. Epsilon is the permittivity of the medium. So this is Coulomb's law. So what is the statement of Coulomb's law? Coulomb's law states that the electrostatic force between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Children, you remember Coulomb's law is valid only for point charges. Okay, here what is epsilon 0? Permittivity of air or vacuum. Now, if the distance between the two charges is doubled, what will happen to the force? You know, F is proportional to 1 by R square. So, in this case, new force F dash will be proportional to 1 by 2R the whole square. So, force become 1 by 4 times, right? What will happen to the force between the same charges if they are separated by a distance 2R? Okay, so you know, now new force I am writing F dash. F dash is K into Q1, Q2 the same. R become 2R the whole square. That will be 1 by 4 into K Q1, Q2 by R square. That will be F by 4. So now new force become F by 4. Okay. This is Coulomb's law. Now we can define another quantity called relative permittivity or dielectric constant. You know the relation between density and relative density. It is a similar equation. It is the ratio of permittivity of a medium to the permittivity of vacuum or air. Vacuum or air is taken as the standard one. Relative permittivity. Relative permittivity. What is the definition? It is defined as the ratio of permittivity of a medium. We write it as epsilon to the permittivity of vacuum or air. That we denote as epsilon 0. Relative permittivity, we can use the symbol epsilon R, R for relative permittivity, or we use the letter capital K. Capital K, it is also known as dielectric constant. Epsilon R or K is known as relative permittivity or dielectric constant. So what is the equation? Epsilon R or capital K, epsilon by epsilon 0. This is the equation. Okay, so what is relative permittivity? How it is defined? It is the ratio of permittivity of medium to the permittivity of vacuum. Okay, if you take air, K or epsilon R will be 1. We can write epsilon equals epsilon 0, epsilon R. For air, epsilon R is 1. We can define relative permittivity in terms of forces also. When the charges are placed in vacuum, what is the force between the charges? F vacuum. You know, K, Q1, Q2 by R square. K you have to write the one by 4 pi epsilon 0 Q1 Q2 by R square. F medium is in a medium, when placed in a medium, 1 by 4 pi epsilon Q1 Q2 by R square. Equation 1 and equation 2. If you divide this, F vacuum divided by F medium, what you are getting? When you divide it, we get epsilon by epsilon 0. This is epsilon R. So we can define relative permittivity in terms of forces also. What is relative permittivity in terms of forces? It is a ratio of electrostatic force between two charges placed in vacuum to the force between the same charges placed at the same separation in vacuum. So this is Coulomb's law. Now you know Coulomb is the unit of SI unit of charge. Using this Coulomb's law equation, we can define 1 Coulomb of charge. Define 1 Coulomb of charge. So we write the equation. When two charges placed in vacuum, we write the equation 1 by 4 pi epsilon 0 Q1 Q2 by R square. If Q1 equals 1 coulomb, Q2 equals 1 coulomb, R equals 1 meter, then what will be F? F will be 1 by 4 pi epsilon 0. Q1 is 1, Q2 1 by R1 square. It will be 9 into 10 raised to 9 Newton. Now we can define Coulomb. 1 coulomb is that charge when placed in vacuum at a distance of 1 meter from an equal and a similar charge, repels it with a force of 9 into 10 raised to 9 Newton. This is the definition of Coulomb. 1 coulomb. So how will you define 1 coulomb? 1 coulomb is that charge which when placed in vacuum at a distance of 1 meter from an equal and a similar charge, repels it with a force of 1 Newton. So this is the definition of 1 coulomb. So I will write here 1 coulomb is that charge which when placed in vacuum at a distance of 1 meter from an equal and similar charge, repel it with a force of 9 into 10 raised to 9 Newton. So this is a definition of 1 coulomb. So today what we basically learned is Coulomb's law. All of you must know Coulomb's law now. Okay. Here there is one limitation of Coulomb law. What is the limitation of Coulomb law? It is used only for point charges. What is the statement of Coulomb's law? The electrostatic force between two charges is, point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between the charges. It is also called inverse square law. And we learned a term, permittivity. What is permittivity? I told you permittivity related to permission, right? It is the ability of a medium to permit. It gives a measure of the ability of the medium to permit electric force to pass through them. Okay. Permittivity of vacuum is represented by epsilon 0. Permittivity of medium is represented by epsilon. Now we learn another term, relative permittivity, epsilon R. It is also known as dielectric constant capital K. What is it? It is a ratio of permittivity of the medium to the permittivity of the vacuum. Or we can define in terms of forces. Relative permittivity is the ratio of force between two charges placed in vacuum to the force between the same charges placed at the same distance in another medium. Okay, dear children, today I will stop the class, today's class. Thank you for watching. Keep watching and subscribe my channel. Thank you all.